My name is Devesh Kumar.
I'm Pavel.
So we are presenting our capstone project, that is book recommendation system using Wikilinks. So basically we all read books, and we will be very happy when someone recommends the book of the same type which we like. So our project contains the book recommendation system based on the Wikipedia links which the people provide after reading the books. So basically we give index for every book and every link, and we recommend books, and the resulting embody enables the meaningful comparison for the recommendation.
Our goal is to take all the wiki links from the Wikipedia articles that relate to books, to recommend books not only using the genre and the name of the book or the author of the book, rather other links which people tend to click a lot, using data from Wikimedia dumps, which contains data sets or text data from Wikipedia articles for a particular time period. We have done web scraping for this, and we have chosen a JSON file that contains these information. It has, in our data set, we have around 37,000 books with 6 fields, which is stored in the form of multi-dimensional list. The first one will contain the name of the book. The second one is a dictionary. In the dictionary form, we have all the information of the info box of the Wikipedia, and the next one are the internal links of the article based off the book name, and the next one is the external links, date edited, the edited date of the article, and number of pages of the article. So, as most of our data is in the form of text, we have made a function called preprocessed text. So, when we are doing the data analysis, whenever we need to choose a particular column, we can call this function for pre-processing the text, so that it can remove punctuation stop words. Like if you have a country, the United States, and the other fields also has United States. So, this may lead to confusion for the system. So, removing the will make our model more efficient and take down the confusions. So this is a screenshot we took from one of the books from Wikipedia article. So this is one of the screenshots we took from the book. The first column that includes the title, and this is the last one that includes the date edited. This is the info box. Now, as we had the info box in the form of dictionary, we are trying to convert that into data frame so that we can view it in a more in a more convenient way. We have these few top columns that are contained in the info box, like name, author, language, country, publisher, and the counts. And after pre-processing, we remove the columns that do not have the book names. These are the links. We have external links which we pre-process and remove. We try to shorten these links. Before we had for books.google.com, the external links for the same website were too many. So we try to shorten the link to know which are the most external links connected to every book. Like people usually go to Amazon or Google Books to learn more about the books or to buy the books. So we try to shorten the links to know which are the most visited external links that are outside the Wikipedia. Data analysis. As we have a very huge set of data, we are trying to create few functions so that you can use these functions to see the connection between a lot of columns rather than just analyzing one column. The first one is our pie chart. Here we can input any data, or we can send any column name. Like here I have sent the genre name, which is pre-processed, and after that we can create a pie chart related to the distribution of the counts or the most occurring genre. Here we got science fiction as per our data set time has the most occurring data. Next is a bar relate. Here we can relate two columns. Like I have related publisher and series. The number of publishers who have the most published series. Series in the sense the books that like Harry Potter. It is a series. So publishers like HarperCollins have published more number of series. And that's how we can relate, and we can use some other columns to like author, which author have written lot of series, or any other column. Next we have pages relation. In our data, the pages column was in the form of text, and few also had like 235 pages. So before trying to find the average number of pages and relating it to any other column, we have first pre-processed it, removed the pages or any words, and then converted the text into numerical form. We have used median because there are a lot of study, or like pharmacy has the most average pages. So if we try to use mean instead of median, it will be too biased, or it will just the graph will just show that the pharmacy reference has like average of 6,000 books, while normal novels have like only 200 pages. So we have used median instead of using mean to show the average number of pages. Next we have used a heat map. Here we have done this in a way that you can choose a particular column like your publisher and take any value of that column. Like I have taken HarperCollins, who is a publisher, and we can relate half the third column, that is the genre, how many type of genres, the number of books they have published in that genre. You can do this for any other column for a particular value, like author, the name of the author, and the type of genre or the type of series they have produced. Here in this chart, we have got to know that HarperCollins have produced the most published most historical novels. This is what we have done for the info box. And then we have plot counts. Here, this is for the links we have used. For the external links, how many links are occurring the most, the counts we have taken into consideration. Here, before doing this, for internal links also we try to plot the most occurring counts of the categories. We had first noticed few categories like novel, paperback that may affect our model. So we try to remove those, and this is the resultant categories we got.
So now comes our model part, which is basically based on our supervised learning. So we extract all the book titles and their external links, and we make them into a vectorized form. So that vectorized form, we can tell whether the book is related and how much it is related to a particular book. So it will be basically on the cosine similarity, which we will see later. So this is our training and testing model, where we have made the batches of the books, the pairs which we have made. So we have made the batches and also labeled them as 1 and -1, which is positive and negative, whether they are related or not related. So the next thing, we have made a book embedding model, which is basically based on the neural network, which shows the relationship and whether they are very much related or not. So it is basically based on classification, and also it can perform regression tasks. So like here we can see a cat is like more related to a living being, but less related to plural or royalty, like that. So basically in regression we have a continuous numerical value, whereas in classification it gives a class to the web links and the books which we have provided. So it gives a specific category to the books. So now we have our evaluate model. This is basically used for the accuracy prediction. So we have given the weight and the book weights and the link weights, and we have our true labels and predicted labels. Based on that, it predicts our accuracy. If the accuracy, like if the cosine similarity is like more than 0.5 or 0.3, it will give as it is more related to. So this is our basis, which is our cosine similarity. So whether the two links are very much related, so it mainly depends upon the angle and the distance between them. So this is our model, and this is the function of the find similar function, which tells us Like here we have taken a book named War and Peace and its weight, and it is giving us that the War and Peace is very much obviously it is similar to War and Peace itself, and now it is similar like 0.3 similar to this book, like 0.84 similar to the red and the black. Also, we have a plot function in our find similar function. So if we give plot as true, it will also plot whether this book artificial intelligence, a modern approach, is how much related to these books and also very much least related to these books.
So as embedding takes high dimensional vectors, we are trying to visualize our embedding by shortening it into a 2D or 3D vector by using the T-distributed stochastic neighbor embedding. As we are using embedding here, our model is converting our links into 37,000 into 50 vectors. Our books are distributed as 50 vectors, which we cannot visualize here. So we are converting into a 2D vector to see how our embedding model is distributed. Similarly, as we said that we had done a few data analysis on InfoBox, we are trying to embed this into the model to visualize this, because when we are doing embedding, it's hard to predict whether our model is saying the right or predicting the right output. So we are trying to visualize it using this embedding model. For example, we have done, we can plot this by giving the column name. Here I have given genre. We can see here that the non-fiction, the green elements are clustered together, while the science fiction and children novels, which are usually not related to non-fiction, are clustered far out from there. Similarly, we can pass any attributes to see this distribution in the embedding model, like here author or the countries.